So if you guys saw in the last video, I talked about how you can use this flame graph to basically dive down into your code base and see where things are taking the most time. And in doing so, I identify that, hey, my rendering of these shadows that kind of lay over every tile was eating up a large portion of the CPU. So I fixed that up. I kind of talked about in the last video. But what I also did was I added a bunch of averaging timestamps. So basically I'm tracking how long does it take to render out all of the ground tiles, how long does it take to render out all the collidables. For example, these trees are considered collidables. These tree stumps are collidables. And then we have particles, entities, darkness, which we just talked about, and then rendering out the UI elements like this minimap. And what I noticed is that the render collidables was actually pretty high. It was at 0.2 milliseconds, and I wondered, is there a way to actually speed this up? Because the current approach I'm doing is I basically have a giant map built up of these biomes. And the overall map is built up of like another 16 of these. So basically, if you do 16 by 16, that's how many biomes or how many tiles exist in a biome times the width of the map times the height of the map. So that's about how many total tiles are in this map as I kind of walk around, if I did my math correctly. And rendering all those out, especially with the way I was doing it, can take up a lot of time. But for rendering out the collidables, this time is actually how long it takes to render out just a smaller subset of all the map directly near the player. So we have a way to basically just find the tiles around the player, and then I look up the different cells to draw them out. And the way this works under the hood is I'm calling the HTML canvas draw image function, which we have a tile sheet that has all of these collidable entities. You see there's a tree here, there's a stump down here. And in the code, it basically loops over like 50 columns by 40 rows and tries to find which image should belong in this map location. So again, like the map I talked about over here, let's say this 5 is a tree. It's going to loop over this, and if it finds a 5, it's going to draw a tree. A 14 will be a different type of tile ID. So I wanted to kind of dive into the renderer and try to look into where it's rendering the collidables. So I went ahead and clicked on that. And this is what the code used to look like. I basically, like I said, I get all the tiles that are visible to the current player, and then I just render them out each one by one with a draw image. But it turns out that there's actually a cool optimization you can do with 2D games, assuming that your actual map is static and does not change. Because instead of having to draw all these tiles every single game render, what we could do is combine them all into a giant PNG, basically. It's actually like an in-canvas memory object. But the idea is you basically do like a pre-rendering step. So you basically have all of these things that are already connected, and then you're trying to transform them into one contiguous image that you can easily load in and render over with like XY locations. So this was the original approach where we basically loop over and render each tile individually with a draw image method call. And the new approach is you basically combine them all. So you basically do with a pre-render step. And then when you actually draw the image, what you can do is just grab the entire rectangle that contains the whole thing. So instead of actually having to drawing out like one by one, you can just say, hey, draw that whole pre-rendered image, put it on the screen with this area cropped out. And then you can, of course, the camera would change it as well. So that's the idea, pre-rendering. Let's talk about how much faster this was. And then we can maybe kind of talk about the implementation of it. Let me just go ahead and refresh, and we'll see over here, render collidables is now 0.033 milliseconds. So it went from 0.2 to 0.03, which in my opinion is a pretty good increase in performance. So I'm kind of satisfied with how much faster this is running. And I basically took the same approach I did for render collidables with the pre-rendering, and I did it on render ground as well, because both the ground and the collidables are static in this game. And I think we can just get that extra performance out by just rendering that out. So let's kind of look at the code and understand what it's doing. So this is the new setup. We have a render pre-rendered layer, which takes in a canvas object, or sorry, a context object. This is the HTML5 context that you can actually like draw images to. And then we get the collidables canvas, and we get the collidables layer in the collidables tile sheet in the bounds of where the player currently is. And those are the main arguments. Let's dive into this and kind of understand how this works. Okay, so step one is we get the canvas, and if it's not defined, we're going to go ahead and just do the pre-render function, which was passed in over here. So the pre-render function is pre-render collidables. And here, you'll see that we basically have a collidables canvas. So that calls into a pre-render tile layer. And this creates a brand new 2D canvas, which down here we basically loop over the entire map. So this is like all of the map put together. Imagine if we were to zoom out super far in this game, you could see every single biome connected together. And then we start building up the final image like I kind of talked about. Now, the reason we have to do all this, and I kind of skipped over a lot of this code, but again, it's just create a canvas, render the whole map onto it, and then we have this cache somewhere so that later on collidable canvas can be used when trying to like render out all the collidables, okay? So again, let's dive back into this method because again, it just did all this. It basically created the new canvas of the collidables. It's a giant internal PNG basically. And now we can actually start using that when we want to render out to the screen. So again, the reason why we pass in get canvas, it's a dynamic function because this is a reusable thing we use for both the collidables implementation to make it faster and also the ground layer to make it faster. So we can pre-render those two different images using this method here as helper function. And then finally, this is where we actually tell it to look at the rectangle around the player. And then we basically tell draw image to position the camera over the image so that we can kind of crop it out and then render it where we need to on the actual canvas. So if in case that didn't make sense, which it might not have, imagine we have a giant image that's basically getting stitched together, right? What we're basically doing is find where the player is. So I'll just go ahead and like put like a little user object here. You'll see the player's right there. We want to snip out a certain rectangle around the main image that we kind of pre-rendered, and then we tell the canvas to just draw this region. So overall, we don't have a double for loop that's happening every single game render. It's just one simple call to draw image. Internally under the hood, the browser has some optimized methods to basically draw the image with that particular location in play, and you'll get a much faster render of that collidables map. And so everything I kind of talked about, I glossed over that. The exact same thing happens with render ground. It uses that helper function there. We cache it to the ground canvas so that later on it can just use the ground canvas and render out that snapshot. All right, that's all I have to talk about. If I did a good job explaining this, let me know. If I didn't, let me know. I want to try to improve my ability to communicate and draw diagrams for you all so I can teach on what I've learned to anyone who might be wanting to watch. And then secondly, leave a comment if there's like another type of optimization you think I should just go learn about. Anyway, that's about it. Have a good day and happy coding.